Let's face it, low water pressure is frustrating. It can turn simple daily tasks into time-consuming chores. Whether you're struggling to take a decent shower, where the water barely trickles down, or your appliances are underperforming, it's a problem that needs fixing. Washing dishes or doing laundry becomes a hassle when the water flow is weak. That's where booster pump systems come in. These systems are designed to solve your low water pressure issues. These handy systems are designed to increase water pressure throughout your home, giving you the water flow you need. Imagine turning on a faucet and getting a strong, steady stream of water. A booster pump system takes water from your main supply and increases its pressure. It works by using a motor to boost the flow rate. Think of it like a muscle car engine for your plumbing. Just as a powerful engine enhances a car's performance, a booster pump enhances your home's water pressure. This pressurized water is then delivered to your fixtures and appliances, giving you that satisfyingly strong flow. No more weak showers or slow-filling pots. Booster pumps are especially helpful for homes with multiple stories, large properties, or those located far from the water main. They ensure that every part of your home gets adequate water pressure. If you're tired of weak water pressure, a booster pump system could be the solution you've been looking for. Enjoy the convenience and comfort of strong, reliable water pressure in your home. Now that you understand the basics of booster pumps, let's talk about the different types available. The two main categories are single pump and multi-pump systems. Single pump systems, as the name suggests, use one pump to boost water pressure. These systems are great for smaller homes or for addressing low pressure in specific areas. Multi-pump systems, on the other hand, utilize multiple pumps working together. This provides greater pressure and flow, making them ideal for larger homes or situations demanding high water volume. Choosing between a single and multi-pump system depends on your specific needs. Consider the size of your home, the number of occupants, and your water usage habits. A booster pump system might seem complex, but it's really just a team of components working together seamlessly to achieve a common goal. Let's break down the key players in this intricate system to understand their roles and how they contribute to the overall functionality. The booster pump is the heart of the system, responsible for drawing in water and increasing its pressure to ensure a steady flow. The diaphragm pressure tank acts like a pressure reservoir, storing pressurized water and reducing pump cycling, which helps in maintaining consistent pressure. We'll dive deeper into its importance later, but for now, know that it plays a crucial role in the system's efficiency. The pressure gauge allows you to monitor the system's pressure and ensure it's operating within the desired range, providing a visual indicator of system health. And finally, the non-return valve is a one-way valve that prevents backflow, ensuring water only flows in one direction, which is essential for system integrity. Understanding these basic components will give you a solid foundation for understanding how the entire system functions and how each part contributes to the overall performance. Section 4. The diaphragm pressure tank, your secret weapon for consistent water pressure. Let's talk more about the diaphragm pressure tank, a crucial component often overlooked in many home water systems. This tank plays a vital role in maintaining consistent water pressure and extending the life of your booster pump. It ensures that your water system operates smoothly and efficiently. Here's how it works. When the pump activates, it fills the tank with pressurized water. This process is essential for creating a reserve of pressurized water. The diaphragm inside the tank expands, creating a cushion of air pressure. This cushion is what helps maintain the balance in your water system. When you turn on a faucet, this pressurized water is released, providing a steady flow even when the pump isn't running. This means you get a consistent water flow without any interruptions. Without a pressure tank, the pump would have to cycle on and off every time you use water, leading to wear and tear. This constant cycling can significantly reduce the lifespan of your pump. The pressure tank acts like a shock absorber, smoothing out pressure fluctuations and ensuring your pump isn't overworked. This not only protects your pump but also ensures a more reliable water supply for your home. Section 5. Sizing your pressure tank, ensuring optimal performance. Choosing the right size pressure tank is crucial for your booster pump system's efficiency. A tank that's too small will cause the pump to cycle frequently, leading to premature wear. A tank that's too large will take up unnecessary space and may not provide the desired pressure boost. Calculating the appropriate tank size involves considering factors like your home's water demand, the pump's flow rate, and the desired pressure range. While it's best to consult with a professional plumber, online calculators can provide a good starting point for determining the ideal tank size for your needs.